calculate the greenhouse effect and we calculate the equilibrium temperature from the sun's radiation, we can pretty much predict exactly what these temperatures are. Using our climate models, the same climate models we use for Earth, we get the right answer. You put in the air of Mars or Venus, you put in the right amount of sunlight, and this is the climate you get. So the first punchline is yes, our climate models work. Yay. That's really good, it's valuable, it's reassuring because we depend on them. How do we know what's going to happen to Earth's climate in the future? We don't have a crystal ball to see the future. We have climate models. And as you heard yesterday, one way we validate those climate models, we learn to trust them, is to look at the history of climate on Earth, on our planet. But another way is to look out at the other planets, because we want to know, if you make a big change to Earth's atmosphere, do we know what the climate will be like? Well, Venus and Mars tell us yes. If we make a big change to Earth's atmosphere, we do know how to predict that climate, and that's reassuring. So that's the climate of the planets today. What about their history? What about the deep past? What do we know about how climate has changed on all these worlds? Well, one thing we learned from comparative planetology from our spacecraft that had visited Mars and visited Venus is that the planets were probably much more alike when they were young. That Venus and Mars show evidence of having been much more Earth-like. Probably all three of these worlds had warm, liquid water oceans when they were young. Which is also really cool because those are the conditions that led to the origin of life on Earth. Which kind of makes you wonder about Venus and Mars. But first question, we want to know what happened, but also, how do we know this about the deep past of Venus and Mars? How do we know what the early climates were like? Well, as you heard from Professor Gouldman and from other speakers, we see a lot of evidence for ancient water on Mars. And there's orbital evidence, there's evidence from rovers, evidence in the rocks, in the patterns of layered sediments. I won't go into this in detail now because you've heard about this, but we have good evidence that Mars, when it started off, had a much more Earth-like climate and liquid water. But what about Venus? Venus is much harder to explore than Mars, and we haven't explored it yet as well or as much. For one thing, it's completely covered by these clouds. You look at Venus with your naked eye, it looks so bright in the sky. That's because you're seeing these bright reflective clouds. You go there with spacecraft in orbit, you can't see the surface, all you see are these clouds. Unless you're very clever and you have an orbiter that can look with radar or with infrared. But it's much harder to see the surface. And then when we do finally get to look at the surface of Venus with radar, what we see is that Venus has a much younger surface than Mars. Many places on Mars look like this on the left. They're covered with craters. There are ancient surfaces that go back billions of years. So we have a chance to find clues to the earliest climate of Mars. But Venus on the right here has very few impact craters. That tells us it's not an ancient surface. Something else has been happening on Venus. And you can see in this image, there's a lot of volcanoes. And that's part of what's been happening on Venus, is that the surface has been wiped out by later geological